Hi again, everyone. Dr. Tom McNamara here for our course in trigonometry. In this video, we are going to talk about using the law of cosines to help us solve a triangle. Specifically, we're going to work on solving a triangle where we know 3 of the side lengths but don't know any of the angles. Okay, so here's our example here. We're going to find all the missing parts in triangle ABC if side A is 26 centimeters. Side B is 19 centimeters, and side C is 15 centimeters. Okay, so this will be my picture here, and what the heck, I'll make it all kind of proportional. This will be side C, which will be 15 centimeters. Side A was the longest one, so I'll make this one side A, and this will be side B, kind of in the middle. Okay, that makes this angle A. This is angle B, and this is angle C. Now, the law of sines will not help us, okay, because all of the angles are unknown. Okay, so if we pick any version of the law of sines, we're going to have 2 unknowns, and we won't be able to solve. However, law of cosines will be able to help us. Okay, let me use this version of the law of cosines here. So a squared equals b squared plus c squared minus 2bc cosine A. Remember, this angle should always be the angle that opens up onto this side. Okay, so if I'm talking about A over here, side little a should be angle capital A. All right, now, I can go ahead and fill in everything I know, leaving a single unknown. Okay, since that's true, this has got to be the case. 26 squared equals 19 squared plus 15 squared minus 2 times 19 times 15 times cosine A. And what we're going to do is we are going to solve this expression for cosine A. And then if we know the cosine of our angle, we can use an inverse trig function to get our angle. All right, so I want this by itself. Subtract this away, divide this out. Okay, so cosine of A. Now let's think about what we're doing again here. I want cosine by itself. I need to subtract away the 19 squared. I need to subtract away the 15 squared. So I would have 26 squared minus 19 squared minus 15 squared. That whole thing would get divided by negative 2 times 19 times 15. Okay, if I did all those steps on the right-hand side over here, I would have cosine A isolated, and that would be on the other side. All right, so now we can do some number crunching. Okay, so 26 squared minus 19 squared minus 15 squared equals, we're going to take that and divide it by negative 2 times 19 times 15, being careful to put the entire denominator in parentheses. Okay, so this is what I'm getting. I'm getting cosine A is equal to negative 0.15789. Now I can get angle A by doing cosine inverse of negative 0.15789. Okay, so let me do that. Cosine inverse of the answer you just gave me. Okay, I'm getting 99.1, and my calculator is in degree mode. So angle A is approximately 99.1 degrees. Let me use the convention that I've done before. All right. Now, that was a little tough, I grant you. Okay, there was a bit of tedious algebra to go through. So, while you could use the law of cosines to find all the angles, I don't recommend doing that. I recommend falling back on the law of sines now that you've got one of the angles. Okay, so I'm just going to keep my picture up there. So now we're going to use the law of sines. Okay, so we know angle A, we know side A, and one version of the law of sines says this: sine A over A equals sine B over B. So we'll fill in all the known variables, leaving a single unknown, angle B. So angle A we just computed using the law of cosines, 99.1 degrees. Side A was given to us, 26 centimeters. That should be equal to sine B, angle B is unknown, over side B, which is 19 centimeters. Okay, B is going to be equal to sine inverse of 19 times sine 99.1 degrees over 26. Okay, you want to get sine B by itself, multiply the 19 over. If you know the sine of an angle and you want the angle, got to use an inverse trig function, got to use inverse sine. So we do our number crunching here. Sine inverse of 19 times sine 99.1, close that parenthesis, divide by 26, close that parenthesis, equals, and I'm getting approximately 46.2 for angle B. So that's on there now. And one more thing, we have to find angle C. It said find all the missing parts, and we didn't have any of the angles. Now that we've got two of them, we don't need anything fancy to find the third. We're just going to use the fact that the sum of the measure of all the angles in a triangle has to be 180. We already know two of them. That means there's no choice left as to what this one is. So we can take 180 minus 99.1 plus 46.2. And I'm getting that this is 34.7 degrees. Okay, and of course we can always check our work. We can add up all those angles and make sure it's 180. Okay, so this is a case where we cannot get anywhere without the law of sines. In the case of knowing three sides of a triangle, you have to use the law of cosines to help you get one of the angles. Now, once you've got that, I would recommend going to the law of sines to get the other angle, and then to find the third, use the angle sum. Okay? In the next video, we're going to do some work with applied problems involving the law of cosines.